So all of these slides will be available for you. There's a bunch of links in here to get started on what we're going to be talking about today, some educational resources. I probably don't have to explain too much. This is a highly technical audience, which is always nice talking to, because a lot of times we go in and we start talking about AI to people on Capitol Hill, senators, congressmen in the United States and abroad, members of parliament. And I swear, sometimes I feel like I'm talking to them and they couldn't spell AI if I spot them the A and the I. And they just don't seem to get it. So when we bring up a term like MLSecOps, they say, I thought you were talking about artificial intelligence. It's like, yeah, let's hold on that. So I'm just going to go ahead and get started with a little bit of preamble, and then we'll get into the meat of the content at about 3 minutes from now. So a little bit about Protect AI. Protect AI is a small company, but all big companies were once small. We've been around for about 2.5 years. These numbers are old. We have now over 90 employees. So this was when we submitted to RIMA a week ago. But we also have over 12 AI/ML security events per year. We have a number of local chapters. We will be starting one in the tri-state area in January. We're very excited about that. It'll, of course, be focused naturally on financial services. But we're very excited. We've raised a sufficient amount of capital out of interesting stat that was given to us by actually JP Morgan's bankers. In the last 3 years, there's been about $300 million in invested capital in AI security, and we've collected about $110 million of that. So we're really excited about our position. But what's most relevant today is our commitment to open source. We have over 3 million open source downloads per month of our AI/ML tools, which are all going to be listed here. I'm going to talk about what those things are. Our commitment to that, we have over 3,000 GitHub stars. Not a ton, comparatively speaking, but we are pretty proud of that. And we have over 200 project forks. Our single best motion of getting our commercial products has come from the open source world. So one of the most common things that has happened is our tools like Model Scan or AI Exploits or LLM Guard have been downloaded by SecOps teams, ML teams, AI development teams within the banks. And then next thing you know, we're getting a phone call to try to give them details on what our commercial offerings are. But our commitment to open source goes pretty broad. We have 3 different communities that are focused on kind of different components. One is hunter.com. If you are interested in bug hunting on AI/ML or lining some pockets and some extracurricular activities, visit this. Because we launched it a year ago. We now have over 16,500 hackers and security researchers on this from across the globe. We've paid over $2.5 million in bounties. We essentially take those bounties as a way to understand where the attack surfaces are. We can then create new signatures and model scanners and capabilities as we've integrated into our products. But this is a huge component because we start with open source assets in the MLOps pipeline. So if you're familiar with things like MLflow or Hugging Face Transformers or those types of tools, we bounty those every single day, and we get tons and tons of bugs that come in. But we also double bounty the maintainers. So we pay the maintainers for the fix. And then what we do is we provide that fixed alert, both the kind of notification and the alert through a product, to your threat vulnerability management teams, and they get early warning, or they'll get context on things that don't even exist. As an example, we're all familiar with CVEs in distributed software. The challenge is that there's no such thing as a CVE for a model. So when you have a malicious component in the model, there's no way to alert on it except for us. So we consider that our offensive research or the offensive side of open source assets, the red team, if you will. Meanwhile, on the defensive side and the blue team, we're doing a lot with MLSecOps.com. This is a brand safe space. It has all of my competitors are in it. The big companies, everybody from NVIDIA, who's not a competitor, they're a great partner. But Palo Alto Networks, those types of companies, Sneak, all of them are participating in this. But increasingly, a lot of policy regulators and lawyers because of that. And so we have security professionals, lawyers, et cetera, in that. We have a bunch of AI/ML security events, but what we are most proud of and what's most relevant here for this community is really our open source tools at the bottom. We believe that code settles all debate. So when we showed up 2.5 years ago and we said security of AI is a thing, most people said, it's not a thing. And we said, well, we'll make it a thing. And the first thing that we did was we introduced a very easy, very simple notebook scanner for Jupyter notebooks. And I remember one of the bulge bracket firms we walked into in month 1 of the company, I was sitting with the CISO and I said, you're not scanning your data science assets, and then I can show you where they're leaked. So he was like, no, you can't. And he said, I'll make you a deal. If you can show me right now where we have security holes that have gotten and passed my thing, I'll buy your product. Well, sadly, I think he made that deal because it was an open source product and we weren't charging. So I said, deal, but we'll be back when we have a commercial product. And what we did was we went to their open source GitHub library where they promoted a lot of their data science work. We pulled it down and we immediately started scanning their open source Jupyter notebooks. We found API keys, personally identifiable information, all kinds of things that were leaked. And they said, how did this get out? And I said, it's not that it didn't get out. The problem was your scanners detected it, but they didn't provide context for it. And so what happened is your data scientist who put this together ran it through one of your many scanners, and it basically said, hey, on line 3042 of this JSON file, you've leaked an API key. And the data scientist looked and said, who's Jason? Because they don't talk in that space. So we had to essentially say, hey, look, put that in the context. If I put that in the Jupyter notebook and I say, this cell is broken, this thing has an issue, fix it, the data scientist will. So we made it a thing. And then the best salesperson I could have ever have asked for came down and scared the hell out of everybody named Sam Altman. Because he decided to open up ChatGPT to the world, and regulators went crazy, and everybody's like, oh my God, what's going to happen? All of this is to say, let's talk about what real AI security is. I think it's important that we level set on what AI security actually means. You heard me say in the preamble in the walk-on this morning that we believe that there's a big difference between security, safety, and governance. And one of my colleagues and friends from JP Morgan Chase was mentioning, she said, where's the line on safety versus security? How do we think about that? And we have a perspective, we're not saying that we're necessarily right, but it's a very opinionated perspective, that says security is about things that you know that you can control, that you have done a binary state on. Did you scan the model? Does it have a license? The basics, right? And so I'm going to break that down into how we see that. Then we're going to talk about how you build security in. Now, everybody in here is likely familiar with DevSecOps. That has been preached and enforced into our brains and keys for the last 5 to 6 years. Here's a spoiler alert. When it comes to security of AI, 90% of what you're doing, just keep doing. Right? It's that last 10%. So we're not here to say, oh, it's a bunch of fairy dust things and you need a Ferrari when really a Chevy will do. So let's talk about what that is. And then last but not least, we'll talk about what MLSecOps is and how you put that into practice. But first, I love it when people try to complicate AI. AI is actually really easy. Don't take our word for it. Take CISA, right? I'm not saying we have to believe everything the government says, but in this case, it's very simple. AI is a type of software system. But fundamentally, what is different about AI versus everything else? And like we had panels and risks and this and that, but the reality is it comes down and it's pretty simple. What makes AI separate from every other form of software is a new asset in your infrastructure, and that asset is the machine learning model. Whether that asset and that machine learning model is given to you by OpenAI and the people at Microsoft in a commercial capacity, or whether it's your team of data scientists building it from scratch, or most likely they're downloading it from Hugging Face or downloading it from an open source repo of some kind, modifying it, bolting on the data sets and pushing it through, it's just an asset in your inventory. And your security teams right now can go across the network and find all of your devices, right? They can say, hey, where's your laptop? What is it? Where is it on the network? What's it contain? What's the operating system? What files? What permissions? What was the websites that it accessed? You have all kinds of capabilities. And then you have the ability to shut those things down or force upgrade them, patch manage them, alert a manager, alert a person, put a runbook in. You have all kinds of capabilities. You can do all of those things and time that with a stopwatch. What if your security team wanted to say, show me every application that's using a model that was based on scikit-learn version x.y? That thing's not going to come back to you with a calendar. It's going to take a long time, which means you have assets in your infrastructure where you don't know where they are, what they do, who's responsible for them, what they contain, and unlike any other asset, they self-execute. from the minute you open them. Developers love to attach files to emails and ship them around, right? Great. All of our firms in this room spend more time scanning PDF and executable files than we do models, and models have remote code execution built in as a feature, not a flaw. So when you have hidden assets where you don't know where they are and they can self-execute, you should probably take some capabilities to secure them. And the thing is, people have been doing this for a while. And I said this earlier, when you talk to people and they say, well, we're not really doing AI yet, what they mean is Gen AI. And the reality is every single company in this room today is using AI in some capacity and using ML models. And I gave examples about that earlier. This is just a collective slide for anybody who wants to pass it around for other people when you get it. But the real issue here is that the model files themselves, those assets, are very, very opaque. They contain processed data. They have training code in them. They have model. They have raw data, evaluated metrics. They contain all of these things. And we don't know, unless you have the right tools or the right processes, you don't know how these things impact. So models become a really great place for threats, vulnerabilities, and exploits, which are 3 different things, to all live and hide out in. And those models, which are highly opaque, really kind of are the crux. Their models are complex. Model architecture, the training data, the model registry, all the assets that are used are pretty complicated components. And so the mysticism of AI and the complexity of machine learning models has led to this really weird thing that's happened in the world where we think the robots are going to take over. Well, spoiler alert, they're not. Ask a plumber if he's worried about AI. I guarantee you the answer is no, right? Guarantee you. Traders? Maybe. But plumbers? No. The reality is that this threat perception is not really the issue that all of us should be concerned about. What we really should be concerned about is the fact that millions of models are downloaded on Hugging Face, and tens of thousands of them have exploits in them. Tens of thousands of them have problems. Here's the #1 attack path. Let me explain to you how this works. Llama gets introduced by Meta, the company. They post the Llama 7 billion parameter model up under Meta-Llama-7B. Somebody decides to name squat Facebook-Llama-7B and inject malicious code into those models. What happens is a young data scientist or a young AI engineer comes in, they want to do something impressive, they download that model, they bring it into your environment, they open that model, it hijacks their credentials, it starts doing the credential shuffle, it knocks over the model registry, it knocks over the feature store, it starts leaking training data, and it has a call to a random S3 bucket that's empty. We see this happen every single time a new open source provider creates a new model. And we have the ability to scan inside of those models and see why and where they're broken. There's a reason that existing security companies have not thought about this, because they don't have that context. And then there's the real simple stuff, such as storing passwords in Jupyter notebooks, right? Just basic stuff. The scanners miss it. Why? Because they don't have context. So we need to start thinking about how do we bring context in things like threat vulnerability management, things like scanning, things like inventory management, things like patching, all of those systems. How do we bring that to bear, all the things that we're doing today? Well, you do that by complementing and doing exactly what you're doing today, which is secure by design. I'm sure every firm in here uses secure by design principles. They think about security in shift-left constructs. You're building in developer tools. You're doing all kinds of things to ensure that those code pipelines are safe and secure. And to do that, what we've done is we've basically taken DevOps, the infinity slide, right? Everybody's familiar with this. And when you think about DevOps, it's pretty standard, right? In the dev side, you've got the planning, the coding, the building, the testing, and then you have this continual release, deploy, operate, monitor, pipeline, and you're constantly evolving this. And we said, hey, the problem is a lot of security and governance issues are going to be broken. So you know what we need to do? We need to put security into this. So when we start thinking about what these steps are, when we want to add security to these steps, these are the extra things in gold that we do. So we build in security requirements in the planning stage. We build in threat modeling in the planning stage. We build in secure coding practices in the planning stage. This is all familiar to all of us. We add SAST capabilities. We add DAST capabilities. We add SAST when you're building the code, DAST once it's deployed. We do pen testing. We do security monitoring to watch the state changes of the code and all those things. But then everybody says, oh, but AI development's so different. It's so complicated. There's this, magic fairy dust that comes in and spreads it over, and AI is going to solve the world and destroy the world at the same time. I never know which side of the debate I'm on. But here's the reality. MLOps, which was the term that Gab used today, he said regulated MLOps. We love that term. We just call it MLSecOps, right? The important thing here is that some of the terms might change when you talk to your AI engineers or your machine learning engineers or AI developers and they start talking about MLOps. Don't get confused. Basically, the planning stage is changed with scoping. That is a term that you will hear all the time when they start talking about scope of the model, scope of the AI application. It's no different than the planning stage. Similarly, the code component, instead of just coding, because they're AI engineers and ML engineers and they got these fancy PhDs, it's not good enough. It's data preparation. It's data prep. There's a lot of data prep work that we got to go do. We agree. We understand. All of our backgrounds in our company are from AI. And then it's like, well, we're going to build, right? We're going to code. No, we're going to model train. It's very different. Not really. Those are the only three things that change. And it's just terms. But the functions do change, right? So when we talk about scoping, it's really about task identification, the suitability, requirement engineering, data suitability, really understanding that. A lot of the kind of safety concepts come into this component right here. It's like really thinking through way upstream what you do and do not want a generative AI application to do. What that data collection component looks like in the data prep, the formatting, the cleaning, the labeling. I call it the data janitorial work. It's a lot of fun. Then you get into the really cool stuff, model creation, model training, error analysis, performance tracking. But in between that and scope, oftentimes it's a model selection. Which models are we going to choose? Which vendors are we going to choose? Which open source model should we choose? Do we need a 7 billion? Do we need a 750 million parameter model? How do we think about that, right? Because there's a cost on the infrastructure. There's a cost on the team. There's a whole bunch of things that you have to consider. But the rest largely stays the same. But when you start thinking about the security change, remember what I said, 90% of what you do, you need to keep doing? Keep that in mind. Because the only things that we would suggest that teams, particularly in finance, need to do is add these things in blue here, right? So one of the things that I guarantee you is not happening right now is threat modeling early on for AI development planning, right? Traditional penetration testing, traditional red teaming won't work. It's necessary, but it's not sufficient, right? So you need to keep doing what you're doing and then take the next step. You do threat modeling throughout. You notice you do it again in the data preparation and threat modeling refinement. Why? Data leakage becomes a problem. PII leakage becomes a problem. What the model memorizes become a problem. Here's something you can take back to all of the people that you talk to. It doesn't matter what model it is, whether it's Microsoft talking their book or whether it's Hugging Face models that are downloaded. Here's a dirty little secret. LLMs are kind of like the most gifted employee you could ever have with a partially photographic memory. So they come in, they can do almost anything super fast, and they memorize 30% of everything you put in front of them. Now, you don't know what 30% they're going to memorize. There's no actual way for you to actually control that. So you have to be thinking about, hey, even if I feed it synthetic data, it's still going to memorize 3 out of every 10 things I give it, right? And it's going to try to improve. Doesn't matter what the model is. Sometimes it can be a little less. Maybe they're not as smart. Maybe it's only 20%. But generally, the ceiling is about 30%. This is important to remember as you think about choosing a model, no matter who it's from, implementing that model, no matter what it's doing, right? You have to think carefully about where you're at. But then there's other things that we believe you need to do, such as implementing SCA and DAS capabilities on model files themselves, doing model scanning continuously throughout your testing cycle. And then when it comes into the release component, compliance validation, digital signing of those models, and of course, ML bill of material generation, which isn't happening today and we think needs to happen. And that is one of the most key components to MLSecOps, which is you can't fix what you can't see, and you can't go back and address what you don't know it contains. So AI bills of materials are becoming increasingly important. This is where people are heading on the regulated space. And if you don't believe me, it's not just the regulators, it's the lawsuits. Because think about OpenAI's lawsuit and ask Scarlett Johansson how she feels, right? Or Microsoft's being sued by the New York Times. Because the burden of proof is on the person that trained the model. They say, oh, you used our stuff. No, we didn't. Prove it. How do you prove that? You prove it with an AI bill of material or an ML bill of material that logs every single data set of what was used so that you have confidence. And there are two big standards, open source standards bodies that are working on this. Cyclone DX has their first ML bill of material. We are working heavily with them and influencing that specification. And SPDX, part of the Linux Foundation, that's really driving so much in this space, right? And we're doing a lot on both. So that's another reason that by which we joined. But basically, it is a similar concept, and all it's doing is expanding to include ML-specific information. What that gives you is really model and data transparency. Remember, the model is the asset that you really need to secure, that you need to control, that you need to think about. And data is the stuff that you need to log. You need to make sure that the data sets that are in the RAG pipeline or that are in the fine-grained tuning component have permission, that like it meets your regulatory and compliance stuff. Has the PII been done? Is it PCI compliant, right? Do you have authority to use it? Is it synthetic? Is it not? All of these firms, all of you have such advanced capabilities. Just make sure that your ML teams are embracing that. And then, of course, the model info itself. Now, a lot of people will ask me, hey, we do model cards. Is that the same thing as bill of materials? And the answer in our worldview is no. A model card tells you how it was performing. It gives you kind of an F1 score if you're familiar with that. It'll give you all kinds of metrics about what the model is doing and its predictive capacities, but it doesn't tell you who made it, what it contained, what pipeline it's in, what the pipeline assets are, what it was packaged with, where it's deployed. It doesn't tell you all of the information you need. And so as a result, our view, our belief, is that a model card becomes a new type of field that goes into that AI bill of materials that then gets fed up into your traditional ML-BOM processes, right? Pretty simple. Because that model is an asset in your supply chain, right? And you need to understand as much as you can about it. But here's the interesting thing. One of our partners, Microsoft Azure AI Studio, is a wonderful tool. It's in a lot of these banks, right? Well, guess what? That component, once you download a model or you use a model inside of that, it has its own supply chain, right? Azure AI Studio allows you to pick the best packaging patterns. It allows you to pick model format files. It allows you a lot of flexibility, a lot of capabilities to develop really cool stuff. But that supply chain can be corrupted, and you need to understand when something breaks or when something is vulnerable, you have to be able to fix and repair it, right? And certain times, models are interesting because at certain points, when you have an issue in a model file, you can't just force upgrade it. You have to pull it through the retraining pipeline and retrain the model. That's a costly proposition. Ask people about retraining budgets and they get a little wonky, right? But you have to start thinking about that. The supply chain will tell you the libraries, packages, the development language, the framework. That's, by the way, the framework is 9 times out of 10 where we find the most vulnerabilities that are CVE capable, if you will, and put into those assets. And then, of course, the applications that leverage the models. One of the most important thing is not the model file that people want to know. They want to know which applications are using which models. There's a coupling there, right? It's very, very important that we think about that. And then what are the connected downstream data systems? And again, you need to integrate this with the rest of your bill of material processes. Fundamentally, the MLSecOps entities are all about taking what you can, what you know, and integrating that into your traditional SecOps processes. And there's standardization. I talked about this earlier, right, for sharing and collaboration, and we mentioned Cyclone DX and SPDX. We're very, very excited about that. Now, one of the things that you're going to hear from almost every single one of your GRC team members who are involved or connected to your teams is going to be, well, how does this align with NIST's AI risk management framework? How many people have heard this term of some capacity, right? I'm sure the closer you get to the GRC teams, the more they're going to ask about this. And this isn't the only framework, by the way, right? MITRE has one in Atlas. It's similar to ATT&CK. If you're familiar with the ATT&CK cybersecurity framework, Atlas is essentially its AI complement, right? The EU has one. Almost every single intelligence agency has one. And for the first time in history, the National Security Agency published their AI security framework, and I think it's really brilliant. It's very good. I would encourage you all to go check that out. Hit me up if you want a link to that. Others that are more familiar and are still members, Databricks has their AI security framework. It's really, really good. We have a very strong partnership where our products, as an example, ship out of the box with policies mapped to that security framework. So if you're a Databricks shop, you just plug it in, turn it on, off you go. But there's a bunch of them. But this one is the one that's getting the most, I'd say, uptake in the open source community and in regulated industries at large. And really, when you think about aligning MLSecOps, our view of that process, of that tool, of those capabilities, into these risk management frameworks, it basically breaks down like this. If you look at the NIST AI RMF, there's 4 components to it: map, measure, manage, and govern. On the mapping, it's data readiness, model training, threat modeling. It's all the things that we talked about going back to this, right? All of these steps fundamentally are about doing the things in blue here inside of your SecOps processes and inside of your code components. Measuring, model scanning, was it scanned, doing the SCA, SAST and DAST capabilities, benchmarking those scans, benchmarking the performance, understanding those capabilities. Policy enforcement, our company is a big believer in OPA. If any of you are familiar with OPA, all of our products are built using OPA. We take a microservice-oriented approach there, which is nice. But the capability to write one policy or write a collection of policies that extend across your architecture and can be enforced at any step of that is really important. And then we talked about management and security posture refinement. We've all heard of cloud security posture management and all those tools. AI security posture management is just a subset of that. It's a set of derivatives that you have to make sure that you're understanding those assets on. And then govern, woven throughout the entire process from scope to deploy to monitor, right? That infinite loop as we see it. And when you put it all together, it's really about taking together what's in this room, people, and the processes you already have. The majority of the technology you already possess, but you have to start thinking about certain capabilities. And since we are at the open source community here, I would encourage you to go look at our open source tools to get a start. AI exploits, model scan, and LLM guard. The 3 most popular things that you should take a look at to start playing with. The LLM guard, as a spoiler alert, it's one of the backbone assets used by almost all the major security companies in some form or fashion for their AI guardrailing. We're very, very proud of that. So today, what I would ask you to do is download some of the resources that we talked about. Network with others here, talk to me, get engaged. Ensure AI/ML vuln information is in your feed, by the way. If it's not, reach out to us, right? Because here's a spoiler alert. A lot of them don't have this. You have CVEs, you have other package components, but I guarantee you very few of you, I know, have AI/ML feeds on models, model files, and to a lesser degree, open source data sets, like what is corruptible. We provide that. And then, I always had in the next 30, and then I realized I'm talking to banks, and I'm like, I probably need to extend that timeline. In the next half year, establish an MLSecOps COE. One of the things that we've seen in some of the critical industries of finance, energy, manufacturing had been modeling what has happened in the intelligence community. Our first customer was the intelligence community of the United States. when I started the company, if somebody had said to me, our first contract, our first 2 comma contract would be from the US government, I've been like, get the hell out of here. No way. They move so slow. But damn it, I'll tell you, when somebody's got a mission, budget's no concern. And what we realized is that they had already developed certain architectural patterns that started thinking about this 5 to 7 years ago, and we didn't know that. And so what we've done is worked with them to surface a lot of those capabilities in terms of how people think about security of a model file all the way out through security of the perimeter and monitoring what happens in an AI application or an ML model that's put out into the wild. Begin those regular touchpoint meetings. You can do it yourself. You don't need to wait for something. Get a crew together from Sec, get a crew together from AI, get a crew together from the coding team, and you can do it. We have worked together on some stuff where teams are already doing a lot of this with just kind of intrinsically. And so we're very, very excited about that. And so to download the resources, my request is go here. MLSecOps.com is a community-oriented link. We have a lot of podcasts that talk about this. We have a lot of technical components, regulatory components, ethical components. There's all kinds of content in there. You can also get certified in MLSecOps for free. It was the first certification component we launched. We launched this at the behest of one of the largest sell-side institutions in the world, who happens to be a big customer of ours. And we created this. They said, hey, the CISO told us that they wanted a way to make sure that all the employees who were responsible for this had a baseline level of knowledge. So we launched this as a free curriculum. And throughout next year, what you'll see is, again, free curriculum, free leveling up, if you will, of these types of things. So I'd encourage you to kind of really understand that. That's led by Diana Kelly, our CISO. She's really, really great. The content's super easy, self-paced. I would strongly encourage that. And then, of course, play with the tools. Get a sense of where models are vulnerable and how they're vulnerable. So go to our GitHub, and again, the 3 I'm going to keep coming back to. AI exploits. Why? It's great penetration testing tools on your environment with nuclei scanners and the like. You'll be surprised what you find. 2 is model scan. It's one of the most advanced model scanners out there. It's better than a lot of the commercial providers that are there, and it's open sourced. I think it covers like 9, maybe 17 model formats now. I can't remember when our last contribution was there. We're pretty responsive. We have a team that works on that. So model scan is the other. And then LLM guard. Why? Because you can't talk about AI without Gen AI. And everybody loves the prompts and the responses and things like that. And during the talk earlier, there was a conversation about in the panel around what I would call the shared responsibility model of AI models for where security and safety are going to be. If you compare that to the cloud, it's going to be on us to determine what we deem safe and appropriate and governed use. So there's going to be a baseline level of security. But one of the things you want is the flexibility of your LLM to kind of move up and down in the org chart, right? So we have open source tools that allow you to do that. One of the things that we've done, which makes this super easy to use in that repo, is there are individual scanners on inputs and outputs that you can actually just hook into very, very simply. They are small models. They're deterministic. We don't use LLMs to guard the LLM on this case. We think that's kind of... The determinism allows you to have much greater performance, and it can be more CPU cost optimized, so you don't need a GPU farm to actually test it, right? And play with it. And of course, it scales linearly with performance capabilities. And then last but not least, if you want to understand, research the open source threats, go check us out at hunter.com. Again, that's almost 17,000 members now. It's growing leaps and bounds. We're really, really excited. It's a great way to earn some side hustle money too, by the way. We pay fast because we triage fast. And of course, there's more resources here. NIST, Security Risks in AI and Machine Learning, that's a beginning guide, and a beginner's guide to hacking AI and ML and working backwards from that construct. And so with that, I am trying to stay on time, and hopefully I did. Thank you.